My name is Patrick Ryan, and I'm joined today by my colleague Lou Zhang, and we're very glad you could join us. Lou and I are solution engineers on the National Government Science and Civilian team. And today we'll be presenting on using data visualization to perform analysis in ArcGIS. In a moment, Lou's going to start it off by looking at some ways you can leverage ArcGIS notebooks and ArcGIS Pro for your desktop workflows. Then I'm going to change things up and look at some innovative ways you can leverage ArcGIS Arcade in your web maps. So again, thank you for joining us. And with that, I'll pass it over to Lou.
Yeah, excellent. Thank you, Noel. Thanks, Patrick. So good afternoon, everyone. Thanks for joining us this afternoon. So Patrick and I, we have a lot of material to go over. So let's just go ahead and get started. As Patrick first mentioned, first section is going to be on Pro. And then Patrick's going to conclude with web maps and ArcGIS Online. And we're going to talk about how data visualization analysis can relate to help you, create a better workflow. So sorry, I just want to quickly mention this key takeaway, that Pro is really this end-to-end platform for analysis. Analysis is not just a simple process. It actually consists of many steps. In data engineering, data visualization analysis is just a few parts to this process. So this chart includes some of the typical patterns of user workflows in GIS. This is one of my favorite charts. It comes from the product team. And I just want to apply a quick note right here. Like, this is not a checklist. This isn't linear. This could be an iterative process, but you can kind of see the general theme, right? You start out with raw data and you end with a product that, your audience can use. So today I'm just going to take a quick look at the first three sets, data engineering, visualization, exploration, and spatial analysis. And hopefully this can set the baseline for the other four components that you can take a look later, either during future webinars or documentation. So let's get started with data engineering. So when you run a tool, a geoprocessing tool, or any tool part of any software, the data needs to be in a certain format for the tool to run well, right? In data engineering, it's the process to turn your raw data into analysis-ready data sets that you can feed into the tool. Data engineering is a really broad subject, but it will typically include, transforming your data into the right format. This could be, different types of file formats. If your data has holes in it, data engineering is filling your missing values and typos. If you're running an analytical tool, such as regression, data engineering means to you, such as normalizing your data so that your outputs actually resemble something reasonable. And lastly, since we're all working in a GIS environment, data engineering can also include geocoding your data and adding it to your map. And last but not least, you can also enrich and merge your data, right? This could be a relational join or spatial join to produce those additional contextual predictors when you're running some heavier analysis. And here's how you can conduct data engineering in ArcGIS Pro, right? So ArcGIS Pro can help. We have a bunch of off-the-shelf geoprocessing tools, to help you update the schema, create new fields, calculate new fields. But the strength of Pro is also its ingestion and conversion capabilities, right? So many of you have all different types of files, formats that you work with. We can make those consistent and ingest it to the GIS so it can help interact with all of the other data sets that you have. And I also want to mention that these data engineering processes are built into one of our existing tools. So this might not be explicit, but if you run many of our analytical tools, it automatically normalizes the data for you. It fills in the holes in your data, imputes it with default choices so that you get the right results. And if you're using ArcGIS Pro today, I want you to stay tuned. So for the next release of ArcGIS Pro, there's going to be this new data engineering geoprocessing toolbox that's coming soon. And this will give you additional capabilities to data engineering, such as more advanced transformation, dimensionality reduction, and other ways to engineer your data. And if you're more comfortable using Python notebooks, you can do that straight in a pro environment as well. So I'll show you in a demo, you can open up a direct notebook connection in a pro interface and use your favorite Python libraries to tidy up your data and ingest it into a GIS. So once your data is tidy, now you can kind of visualize it, explore it to learn a little bit more about your data, right? So mapping is always a great way to explore your spatial relationships, but combined with symbology, it can also help you find more granular patterns. And if you incorporate symbology in conjunction with charting, we can actually derive some pretty specific insights without even running, any specific geoprocessing tools. And overview visualization. Here's just a few of the ArcGIS Pro components that applies visualization, right? Because it is such a broad domain. So, and the one I want to cover today is bivariate mapping. And the advantages of using this complex symbology is that it helps you find patterns between two or more different columns, right? So if you have two fields in your attribute table or your features, you can visualize them at the same time through a specific color scheme. And this really highlights those relationships. It's kind of like scatter plotting through symbology and helps you detect those outliers. And this is an example that I really like, right? So as you can see on the map, these are housing point locations for the state of California. And I want to point your attention to where my cursor is, right? So using this bivariate symbology, I can choose the y-axis as the median income and the x-axis as the median home value. So as you zoom across the Silicon Valley, you can kind of see that this area has high income and high home value. However, as a policymaker, you're probably more concerned about those areas that have high home values below median income. And this could cause a lot of different issues in this area, right? Such as home unaffordability, homelessness, as well as greater percentage of commuters. So it really, just with symbology allows you to target those areas on the map that you wouldn't typically see. And in addition to symbology, you can use charts, right? Charts are a powerful visualization tool, right? Because it allows you to see tons of information and helps you break it down in an instant. And unlike most charts in Python, the charts that you make in ArcGIS Pro are interactive. So I can right-click on that housing layer and choose to create different types of charts based off of the data that I have. Right? And these charts are interactive, so I can kind of select those outliers with mean high home value but low income, and those selections are automatically reflected on my map. So this is some of the general data visualization technology that I'll show you in a minute. But once you explored your data, you visualized your data, now you can kind of do some spatial analysis, right? You can use some of these heavy-duty geoprocessing tools to get additional insights. And these geoprocessing tools, some of them have pretty complex algorithms, can help you find hidden patterns throughout your multiple variables, also through different dimensions, right? Whether that's time or altitude. You can optimize your data to find those best locations, as well as make forecasts and predictions with those machine learning tools. But the kick is that we offer these spatial components within these algorithms. And here's an example of how you can conduct these analysis in ArcGIS Pro, right? So we break down these analytical tools into 3 components. First component, pretty self-explanatory, right? Classification. Right? And this could be land classification. What are the odds that this is water as opposed to another land surface? We also have a bunch of different tools for unsupervised learning, right? These tools help you detect patterns that you didn't even know you have in your data. And lastly, we also offer a bunch of prediction tools, whether that's regression with spatial components or interpolation techniques to help you create that smooth surface. And these tools are easy to run. Ingest your parameters, and you should be good to go. So that's an overview of some of the tools corresponding to ArcGIS Pro that helps you with engineering your data, visualizing, and conducting analysis. Let's put it all together in a demo. So I'll show you data engineering with ArcGIS notebooks in ArcGIS Pro. We'll do some symbology and do some charting and visualization and conduct some spatial analysis. And the data set, as you can see here, as I'm switching over to ArcGIS Pro, is actually a hail data set. Oops. So this is a Jupyter notebook straight into an ArcGIS environment. And you have ArcGIS Pro 2.5, you can insert a Jupyter notebook straight into your Pro interface. So by doing so, I can go ahead and ingest some hailstorm data sets. You can see here over 60 years worth of hail data from the NOAA Storm Prediction Center. So I can go ahead and download this data set. I can combine it with a pandas framework to visualize my data set in a table format. I can see all of my columns and relevant fields. And just part of the process, I can go ahead and take a look at the schema. The fields all look great. One area of concern is that you can see here that the date field, it's in an object format. So we can use Python to turn that into a date time. So we'll have an easier time conducting analysis. We can do a quick description of important variables, right? So there's 354,000 hailstorm reports, and you can see the mean loss is 19,000, but most reported hailstorms are inherently harmless. 75 percentile still has zero loss, but the most expensive hailstorm costs $2.3 billion, so quite a lot of cash. So you can describe your data set in this notebook with an ArcGIS Pro. If I wanted to impute missing values, I can go ahead and check for it. Well, in this case, we don't have any missing values. And we can take a look at the most impacted states by grouping the count of the hailstorms by state. So from this analysis, we can see that you can see that Texas and all these Tornado Alley states have the most reported hailstorms. And now, using ArcPy, we can now geocode our data set and add it into our geodatabase as a feature class. So you can continue your work in Python in this environment. But for example, let's go ahead and visualize our results on a map. So the first thing we might want to do before adding it to the map is to play around with our symbology, right? So in our case, we might want to create a heat map to explore exactly where these areas of high hail density, right? And right off the bat, you can kind of visualize and sketch out, where Tornado Alley is. Another question you might ask is that, do these areas receive the most damage? So let's take the 2018 hail data and apply some bivariate mapping to visualize this relationship. So go ahead and turn off on this layer. And in our example, we're going to choose field 1 as the magnitude and field 2 as the loss. So I turn on the symbology here, we can kind of see that the strongest hailstorms are in shades of purple, and the most costly hailstorms are in shades of blue. So in this northern Iowa area, you can see that many of these hailstorms are indeed destructive, mainly due to their sheer magnitude. But from a fraud perspective, I might want to take a look at these areas, these hailstorms with low intensity but high damage, right? And using this bivariate symbology, you can kind of zoom into this blue shaded dots. So here's one that's right off the suburbs of Sacramento. And we take a look at the fields here. You see the magnitude entirely very weak, but it did cause quite a lot of damage. And the reason why might be because it occurred in such a densely urban area. So we can also confirm these observations using some of the charting, right? So let's go back and zoom out to the US and turn on some of our scatter plot capabilities. So I can go ahead and right click this layer and go ahead and create a scatter plot to visualize this relationship. So we can choose the x-axis as a magnitude and the y-axis as the loss. We can go ahead and normalize our axes a little bit since many of these hailstorms did cause quite a lot of damage. So we'll set the upper limit to $1 million. And we can go ahead and select those areas that inherently has weak magnitude hailstorm, but still cause some damage. So we can go ahead, select our area that we want to analyze. And if we pay closer attention to the map, you can kind of see the dots I selected are also highlighted on the map, including this area of Sacramento. But you can also see other similar areas where the hailstorms were inherently weaker, but still caused some damage, including these 4 hailstorms that occurred over this pretty dense area over Albuquerque, which is a residential area. So to conclude, let's go ahead and create a few more charts. So we might want to take a look at the historical trends of these hailstorms, right? Are they getting more intensive or are they getting more costly? So let's go ahead and create a bar chart to visualize this relationship. So we can choose the category or date as the year, and we can choose the aggregation as the y-axis. So if we turn on this layer and notice on the chart, we can see that the number of reported hailstorms did exponentially increase ever since the late 1980s. And to get a general idea why this might be the case, we can also visualize our bar chart by another aggregation technique, such as the average of the reported magnitude. And if we apply this, we can kind of see that all the magnitude of these reported hailstorms has gotten a little bit weaker, right? So we can kind of make a conclusion that the number of hailstorms that were historically reported in the 1950s were inherently a lot stronger, whereas in recent times, even the weaker hailstorms are now reported. So before I pass it off for analysis, let's just go ahead and create one more chart. And this is going to be a calendar chart. So using the calendar heat chart, we can take a look at the annual patterns of hailstorm frequency. I can choose the date as the axis, and the count as the heat symbology. So from this chart, we can kind of take a look at March is where thunderstorms starts to flare up, and we go ahead and select these areas. You can see the hailstorms typically are more limited in the southern states, right? Because during this time of the year, the northern states still are a lot colder. But as I unselect this and choose somewhere during late July and August, the map updates, and now these hailstorms move up north as these northern states start to heat up. So with that being said, once I have done my analysis, the initial exploration, visualization of the data, I can now use some of the sample geoprocessing tools to perform more advanced spatial analysis. So I'm just going to run through a few techniques, and then I'll pass it off to Patrick. So again, here are all the hail points. And just to verify our initial observation, let's go ahead and use the space-time cube tool to bin all of our data into spatial bins and temporal bins. So now that we can get that space-time cube and perform some space-time analysis. So now we can visualize our space-time cube by the corresponding trend, which is going to use a Mann-Kendall statistic. So we can now verify whether hailstorm has actually been increasing or not. So this kind of confirms our observation You can see for most of the country, the number of hailstorm reports has increased with a 99% confidence. So if I click on my neck of the woods in DC, you can kind of see that this is indeed the case. We can use some additional tools, such as interpolation techniques, to determine exactly which areas receive the most strongest hailstorms, right? So we can interpolate the hail density, and you can see that Tornado Alley usually receives the most strongest hailstorms. The Rocky Mountains and the West Coast, not so much. And lastly, if I wanted to also incorporate the spatial density as well as the magnitude of these hailstorms, I can use a kernel density method to visualize the density, but also take into account the strength of these hailstorms. So again, most of these hailstorm and risk areas are over Texas. So these are just some of the tools that ArcGIS Pro allows you to clean up your data, ingest your data, do some initial exploration before conducting some analysis. So that being said, I'm gonna go back to my slide and quickly mention that, again, that you can also perform these same steps using a raster data. So, if you have historical air temperature data, you can conduct a temporal analysis chart to determine whether a specific area has been getting drier or wetter. If you have land classification, you can create a bar chart to determine which land type in the approximate area. And using ArcGIS Pro 2.6, we're always giving you additional ways to visualize your raster. And the newest way that was just recently released is the ability to visualize your raster layer in 3D using voxel data. So the 3D extrusion could be depth, or it also could be time. So latest release will definitely give you a lot more ways to visualize your data and explore it. So that being said, I'm gonna pass it off to Patrick, who's gonna cover the ArcMap, ArcGIS Online components. And I can see your, Patrick, I'm seeing the presenter view. There we go.
Thank you, Lou. We're going to switch things up now a little bit and look at visualization, analysis, and Arcade in a web map environment. So what exactly is Arcade? Arcade is dynamic. It allows you to calculate new data values on the fly, even when you don't own the layer. When the data values change regularly, your symbology and pop-ups labels will all update automatically. Arcade has a lot of similarities to Excel for basic functions, but can also support advanced capabilities similar to JavaScript for when you need to do more. So where do you find Arcade? Arcade is portable and lightweight and can be leveraged across the platform, from the runtime SDKs, the JavaScript API, ArcGIS Pro, and online. It is native to the ArcGIS platform and provides a mechanism for defining and sharing expressions. An expression is a script, a chunk of code, if you will, that returns the value. It can be as simple or as complicated as you need. Expressions are used to perform mathematical calculations, manipulate text, and evaluate logical statements. And expressions are written in the Arcade window, highlighted here. This is where you perform those mathematical calculations, manipulate the text, evaluate your logical statements, and return a value. Your expressions are built from global variables, functions, constants, and even existing Arcade scripts used elsewhere in your web map. Globals are how you access attributes within your feature or other layers in your web map. It is important to note the availability of these variables is dependent on the execution profile. Here you see the global variables for a pop-up, where you have access to not just the attributes of the feature you're working with, but also the other elements of your web map. Like Excel, functions are built-in tools to help you process and clean your data. You can add functions with your expression with the syntax already built in, so you don't need to leave your web map to learn more about them. And it is these functions that make Arcade super powerful and easy to deploy. There are not a lot of programming constructs to learn. And just like different globals are a variable depending on the execution profile, the same is true for functions. The available functions are limited by the execution profile. You can determine this by looking up the function in the arcade window. Here we see feature is available in this profile, but feature sets are not. This is more than likely a symbology profile. Constants are just as they sound and include infinity, pi, and the text formatting functions. The text formatting new line function I will highlight in my demonstration. There's of course some basic structure and logic to familiarize yourself. I won't read through all of these, just point out a few that we will discuss again during the demo. Variables can be assigned to any valid data type, and they are declared with var. What makes Arcade unique is its inclusion of feature and geometry data types. Variables have scope depending on where they are called in your script. Currently only supported in the pop-up, field calculate, and attribute rules profiles, feature set is a function that allows you to access information from other layers in your web map. And Arcade has a library of logical statements and operators, which you can reference on the developers page. How many times have you tried to map a field that looks like a numeric field, but was actually a text field? Well, Arcade can convert that text field to a number, allowing you to symbolize on it. Arcade has a full type system. These are the data types and the rules of how you assign variables, expressions, and functions to them. Arcade allows you to implicitly cast between different data types where appropriate using these predefined rules. And profiles are the context in which an Arcade expression is evaluated and understood. They expect specific input and output types depending on the use case. Today we're going to focus on the visualization and pop-up profiles. And with that, before I jump into my demonstration, I'd like to ask you all how you and your team are currently using Arcade. That's great. It looks like the majority of everyone does not leverage Arcade right now. So let me close this pull out and jump into my demo. So for the first web map, we're going to look at historic forest coverage for the United States. Here in our data table, we can see we have total forest coverage for US states for 1630, and then again about every decade from 1938 to the present. Visualizing on this data, however, can be very misleading. Here we're looking at the total acres in 1630. And we would think that Texas and California had all the trees and that Vermont was not yet the Green Mountain State. A more meaningful way to visualize this data would be to look at percent forest coverage, which we see here. But because this isn't an attribute in our data table, we needed to leverage Arcade to calculate this. So let's take a look and see how that's done. In our style editor, we can access the Arcade window. And we can see it's a simple single line of code where we first want to convert the feature's area from square meters into acres. We then want to divide the forested acres by the total acres, convert that to a percentage by multiplying by 100, and then best practice always has that we want to format our result before returning it. In this case, we are using the mathematical function round to do that. And similarly, if we wanted to see change over time, we can configure other layers with different dates. Here looking at forest coverage in 1938, and then again for 2017. Another great way to visualize change over time is to calculate it using Arcade. So here we are looking at the percent change in forest coverage from 1630 to 1938. And we are using a divergent color scale with an above and below. So colors in green show where forest coverage has increased, and in gray where it has decreased. And we can do, again, the same for our time frame 1938 to 2017. Another great way to leverage Arcade in your web maps is in the pop-up. So here in the bold type, we can see all of the statistics that were calculated using Arcade. So let's go into the pop-up editor and we'll point out a few distinctions to note. So here we can go into our expression manager and note that we can leverage as many Arcade expressions in our pop-ups as we need. Let's take a look at one of these. Here we see a familiar formula that we just used, with the exception that we're formatting our result with the text format. And this is because it's going to be used in a string in our pop-up. And if you ever have any questions about the use of a function, right from the Arcade window, you can search for it and look at the documentation. And here you can note for the round function that if we're looking to format the value for display in a label or a pop-up, it's best to use the text formatting, which we are doing. Another great visualization technique that can help you uncover patterns in your data is a predominance map. So here we see that a majority of states, the predominant year for forest coverage was in 1630, with the exception of a few Western states that have had more forest coverage in recent years. We're also able to leverage transparency in this mapping style. So the darker the color, the stronger that predominance is. So while this isn't leveraging Arcade to calculate, this is actually one of the default smart mapping styles available to you. It lends itself very well to this type of data. So when you have multiple attributes looking at a similar theme with the same measurement unit, a predominance map may be what you want to leverage. The next map I'd like to look at is focused on a topic that is the subject of a lot of my work. And I'm sure that we all have a connectivity story that we can tell, especially as many aspects of our lives have moved to a virtual online environment. But the connectivity story that I would like to tell today is that of the Federal Communications Commission. The FCC is the federal agency that is charged with reporting broadband availability across the country. So here we are looking at the median advertised download speed for US counties. But this is a little misleading, because broadband isn't just download speeds, it is also upload. So we're going to need to leverage a technique that Lou touched on in his presentation, and that is bivariate mapping. So here, we were looking at the broadband score for US counties. And this is essentially a composite index that incorporates both download and upload speeds. So counties in green here have median speeds above the FCC minimum standard, and counties in pink fall below that. So let's take a look and see how this was done. In our style editor, we'll again go to our Arcade window, and we can see that the broadband score is actually a component of two separate scores. The FCC defines broadband, the minimum standard for broadband, as 25 megabits per second download and 3 megabits per second upload. So first we want to create a down score that will index a county's median speed against that FCC standard. So if a county, for instance, has a median speed of 25 megabits, it would be awarded 100 points. Or if it had 20 megabit median speeds, it would be awarded 80 points. And then we do the same for our upload speeds. So a county with 3 megs upload would be awarded 100 or 200 points for 6 megabits. So then we're going to evaluate a series of conditional statements and return a result. So when both our down median score and our up median score are greater than or equal to 100, we're going to return the average of those two scores. In all other cases, we're going to return the lower of the two values. Another great way to analyze your data is to rank it. So let's zoom in to the Washington, D.C. area and look at where I call home in Loudoun County. So here you can see the broadband score for Loudoun is 100, which is to be expected for median speeds of 25.3. Let me see if I can get that to refresh. My apologies. Again, let's zoom in to the Washington, D.C. area and look at Loudoun County. And we can see that for the download speed, Loudoun ranks 9th out of 134 counties within the state, but that it is tied with 24 other counties for that rank. If we want to look at that from a glass half full perspective, we can also note that there are 56 counties with better upload speeds. And taking that a step further, we can see that there's only 11 distinct overall speed categories in which Loudoun ranks 7th. So let's take a look and see how that was done. So in our pop-up configuration window, we'll go to our expression manager and look at our county rank download. So to start, we're going to want to pull the state name from our feature. In the example I gave, it was Virginia. Then we also want to pull that county's median download speed to be able to reference. That was 25 megs in the case of Loudoun County. Then we want to assign the county layer to a variable that we can reference it. And then we're going to filter that layer and look at only those counties in the same state. We then want to loop through all the counties in the state and record the download speed in an array. We also want to count the number of occurrences that is tied with other counties. And then here's where the magic happens. We're going to put that array, we're going to sort it, we're going to put it in an order that we can then pull the index of that. And I'd like to note that we need to add 1 to that because we're using a 0 index. And then we take that result and put it into our string to return. And for the final example, I'd like to zoom into Colorado Springs and take a look at the broadband service level for local census blocks. I'd like to point out first that this data layer has recently been nominated to the Living Atlas of the World, so you can come and explore these arcade expressions in more detail. So you can see that we've classified a census block as well-served, served, or unserved. And this is just building on that broadband score that I shared with you earlier. It incorporates a few more variables and a little bit more complex logic. You can also see here that we're leveraging Arcade to pull that symbology color into our pop-ups, the purple here for an unserved block and the green here for a well-served block. I'd like to point you to a wonderful blog done by Lisa Berry on our Living Atlas team that'll walk you step by step through how to do this. But what I'd like to focus on for this demonstration is how we're able to leverage a related table and return records that are for this census block. So let's dive into our pop-up editor and take a look at how we are able to leverage feature sets to do that. So here, we're going to assign that related table to a variable. In this case, we're calling it by the feature set by ID. We're using the global varia data store and referencing it by the index number. We're also filtering that to just look at consumer broadband offerings. We then want to further filter that to look at only those records for the census block that we're querying. In this case, we're going to use the common GeoID field to do that. We then wanted to declare some variables so that we can populate our results. And then we're going to use a for loop to run through our related records and build our return. Here you can see that we're translating that numeric tech code into something more meaningful with the technology name that we would understand. And finally, down here where we're putting our result together, I'd like to point out the text formatting new line. And this is how we ensure that each of our records are individually displayed on their own line. Again, I'd like to point you to a wonderful blog. If you want to pump up your pop-ups with feature sets, Lisa Berry will walk you through very different ways that you can go about doing that. So in addition to the ArcGIS blog, there's lots of great resources for beginners and advanced arcaders alike. So the arcade documentation is a great place to start. There's lots of online tutorials and learn lessons that you can leverage. There's even an ArcGIS Online group and a GitHub repository. And my go-to is GeoNet's site. So with that, I'd like to thank you for your attention, and we will turn it over to your questions.
Thank you, Lou and Patrick. All of that was really fantastic, and we got quite a few questions from our audience. So thank you so much for everyone submitting those. First question, we're actually going to pass off to Lou. So Lou, we had one of our audience members ask if you could share the demo for Notebook.
Hey, yes, absolutely. So Patrick and I, we're gonna package up our demos and we're gonna send it as a follow-on file item. So you will have access to everything I showed you earlier this afternoon.
Great, thanks, Lou. And then our next question is, so Lou, was your demo part of ArcGIS Online or the desktop software?
Great question. So everything I've done in the first part, that was all part of ArcGIS Pro. So ArcGIS Pro is the latest generation of desktop GIS that Esri has to offer.
Perfect. And the next question is for you, Patrick. Can we write R or Python code in the code editor you were showing?
No, Arcade is a scripting language that is unique to the ArcGIS platform. So you cannot use R or Python within the scripting window.
All right, and the next question is, what is the best way to learn more about each type of spatial analysis that you listed in your slide? I believe that goes to you, Patrick.
I pointed out several resources. There are lots of blogs that you can reference. The Arcade documentation is a great resource. And then the GeoNet site is a great place to come and pose your questions to the ArcGIS community.
Yes, and also if you haven't yet, audience, you can go into the handouts part of our webinar today, and you can download the links to the resources that Patrick was showing us. So, and we just got another question. The slides will not be available. However, we did record today's session, and we will be posting it online and sharing a link with everyone so you can revisit this session again. All right. Well, thank you everyone for joining us today. This was a great session, so thank you, Patrick and Lou, for spending some time with us and sharing these details. We did record, so we will send out a note to everyone afterwards. We also have a survey for all of our attendees, so once you close out the GoToWebinar, you will have a survey that pops up, and we'd really appreciate if we could get your feedback on today's session. So, and with that, we will close out today's session. So thank you so much for joining us.